Okay, so this is our first foray in trying to figure out what I can do to interact with you guys and your questions. So let's see how this goes. I'm hoping to keep this to less than 10 minutes and just really good questions that you guys came up with on the forums that I wanted to address right now. So I have a link in front of you. You can kind of see this page with a link of a bunch of things that I just kind of foraged Google University for and found some things that answered some of your questions. So let's get to it. This video is about questions you had on the motion section, projectile motion and velocity, acceleration, and vector valued functions. And one of the first questions I got was, let's see if I can actually get this to work here. Yes, open it. I do want to open this file. One of the first questions I got was about motion, and somebody asked me if you could do motion in like actual 3D, so not just like up, down, and forward, but if you think about a curveball, if you know anything about baseball, it kind of goes up, down, and kind of out to the side, so you really get a little bit of everything. You get the forward, backward, the up, down, and the left, right, so you really get at that 3D. So I Googled it, and if you have never done this before, there's something called OpenCourseWare that a lot of colleges will have. MIT has a great one where they record some of their better professors, and you can kind of audit courses from MIT, and they're great. If you're ever interested in doing that, you can. I thought about putting some of those videos on here, but to be honest, some of them are like 45 minutes long and a little bit boring. Very good, but a little bit boring for our purposes, so that's why I haven't linked to those. But anyways, so I Googled MIT's OpenCourseWare, and I came up with this. And within here, it's just a textbook that they scanned in about motion along a curve. And the one thing I wanted to talk about is just that idea that motion along a curve, yes, you can have projectile motion, but if you look at this one right here, this kind of shows that like curveball idea that I was talking about. So if you had a baseball that you almost kind of threw along a helix, that's kind of the curve that a curveball would take for baseball. They also actually go a little bit further, if I can find it. There we go. And it says, there is a nice discussion of curveballs in the calculus textbook by Edwards and Penny. They kind of summarize it right here. So if you have a velocity vector for a baseball, it has an I component, a J component, and a K component. And I believe the I component is the 120 feet per second that they are using for kind of like your initial velocity, the throw going forward. Your J component is the 16t and minus 2, and I think that's your left-right value. And this 2 minus 32 here is your up-down component. So if you're ever interested in what would projectile motion look like if instead of just up, down, and forward, backward, you want up, down, forward, backward, and left, right, you'd get something like this. And it looks like, to me, what you'll see is the I component is your forward, backwards. The J component is your left, right, and your K component is your up, down, which gives you a position function of 120t, negative 2t plus 8t squared, and then 5 plus 2t minus 16t squared. This thing right here looks a lot like our projectile motion equation from before, that h plus v sub 0 cosine or sine theta t, and then the minus 16t squared for acceleration. So long story short, you can do all of that front, back, left, right stuff using something like this. If you want to know more, read this. Another question I got is, what about air resistance? What do you do about air resistance? Well, I've done a lot of research on that and tried to build it into questions, but honestly, air resistance depends a lot on the air you're at, what your height is, if there's wind, whole bunch of things. So I found this article about a falling body with air resistance. I looked through a couple and this seemed the nicest explanation. But basically, what I saw here is there's something called the linear air resistance hypothesis, and that says the force due to air resistance is proportional to the speed and is applied in the direction opposite to motion. And then they had this great explanation over here. And it says basically, as an object moves, the faster it moves, the more air it's colliding with, which means the more air there is to slow it down. So your wind resistance is variable based on your speed. It's proportional to speed. That means that there is a linear hypothesis that there's a constant k such that the air resistance is negative k times the speed of the object. This is kind of the easiest way to look at air resistance, but there's a lot of other ones too. So again, if you're a little bit more interested in this kind of thing, feel free to peruse this article. Another one that was asked is, I believe it was Permiti asked this one. Air resistance, I want to say, was possibly Mackenzie, and I can't remember who asked about this one. Permiti asked a question about tangent vectors, and she said, isn't there more than one tangent vector to a line? And there absolutely is more than one tangent vector to a line. So let me kind of show you what that's going to look like here. So if I have this spring, I grab my pen, if I have this spring, the tangent vector, the tangent line, is this line right here. It's the line that would come off the spring in the direction of motion. So that thing right there would be the quote-unquote tangent line to the curve. But the question is, aren't there a lot of those? How can you say the tangent line when there's an infinite number? Well, this is considered the primary tangent line because it's going in the direction of motion while still being tangent to the curve. I could draw another tangent line. I'm sorry, I'm covering up there. I can draw another tangent line this way. It only touches the curve once. It's balancing on the spring, but that's not the tangent line. Now, this one that I drew also has meaning because that would be the centripetal force, I think I'm saying that right, that points inward or outward, so centripetal or centrifugal force when you have this helix if something's spinning along there. But honestly, you could draw a bazillion different lines that only touch once and kind of balance on this thing. But again, the idea of the tangent line, quotey quotey, is the one that goes in the direction, the one that goes in the direction of motion like that. And then last but not least, we've got this last one. Somebody asked, can I use physics formulas for this, or do I have to use the calculus formulas? And my quick response on the boards was, you can use the physics formulas because you know where the physics people got them? They got them from math. So this was just another quick article that I found where it said basically calculus is an advanced mathematical topic, but it's used to model physics equations. So basically, because acceleration is the rate of change of velocity, then your dv equals a dt, this gives you a formula to relate velocity and acceleration. All of those physics formulas, like this one right here, all of those physics formulas came from antiderivatives or derivatives or differential equations. They came from mathematics. So I'm going to say most of the time your physics formula will probably work the same as your calculus formula. I will be honest, I've never taken physics C. When I was in high school, there weren't enough of us who really wanted to take it, so I never got to take it, and we don't offer it in Penfield. But if you are in physics C and you want to share with me some of the stuff you guys do there, I would love that. Because I find that kind of thing very interesting. So that is that. All right, so that's quick recap of questions that you had on the problem set and the topic in general, and that's pretty much what I have for now. So we're going to have another video soon. How does a Hawaiian baritone laugh? It gives a low ha. Ha 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 ha. All right, I am done, and you will get another video soon.